Alright guys, this is graphing absolute value functions. We have already covered what the parent function absolute value, or the absolute value parent function looks like. In case you're not aware, this is the parent function. I'm going to review a little bit how it works and then show you how to graph it and some of the basic properties of absolute value functions. So the first thing we're going to do is we're going to fill out a table of values so that you can plot the points. One thing that you need to remember is that the absolute value is the distance from 0, so anything that you get in here, your answer needs to be positive. So when you set it up, we have the absolute value of -5, which is just equal to +5. Absolute value of -3 is equal to 3. Absolute value of -1 is +1. The absolute value of 0 is 0. Here's where a lot of you guys make a mistake. You'll take the absolute value of +1 and you'll tell me it's a negative, which is incorrect. We're not just switching the signs. Your answer just always needs to be a positive number, so that's still +1. Absolute value of 3 is 3. Absolute value of 5 is 5. So now we have a set of points that we can graph, or that we could plot. We have -5, 5, -3, 3, -1, 1, 0, 0, and these are all just arbitrary points that I've picked out. And 5, 5. Okay, these numbers here are my x's, these numbers here are my f of x's or my outputs or whatever. So if I wanted to graph this, you would just plot your points. -5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. -3, 3, 1, 2, 3. -1, 1. 0, 0, 1, 1. 3, 3, and 5, 5. Okay, so here we go. There's your graph right here. Now there's a couple of properties of this graph that you need to know. Okay, the first one is the vertex. Okay, so your vertex is the point. Okay, it's an actual point. And it's going to be either your minimum or your maximum of a graph. So if you're looking at this, your absolute maximum is going to be right here. It's also, you can kind of think of it as the turning point when the two, when the one line turns from one direction to the other. So the vertex here on this graph is going to be right here. Okay, and that's at the point 0, 0. You also need to know, so I'll write that over here. The vertex is at 0, 0. We also have what are called zeros. So zeros happen here on your x-axis. Okay, they're wherever your graph touches this line right here. So in this particular example for the parent function, there's only one 0. So that's going to be at the origin as well. It's going to be a point. So there may be 1, there may be 2, or there can be none. So it just depends on the graph. So my 0 here is at the origin. Now the next one is important and it's really helpful. You use it a lot when graphing, but you don't really realize it. Your axis of symmetry is the line that cuts your graph in half, which means that if I took this graph, I could fold it in half this way and it would be the same. So that line passes right here. And that axis of symmetry always passes through the origin. So this is your axis of symmetry right here. I call it AOS. And that's going to be a vertical line because this line goes up and down. And it's the line x equals some number. Okay, so x equals whatever x is here. So this number here, your x value for your vertex, whatever value is there, is going to be what x is equal to. So here x equals 0, so your axis of symmetry is the vertical line, x equals 0. So when you write it, you always set it up as x equals and then whatever number that is. So these two values here are always going to be the same. It's whatever your x value is in your vertex. Okay, a lot of times you'll tell me that the axis of symmetry is 0 and you will lose credit on your quizzes and exams. You need to make sure that you set it up as the vertical line. I have some vocabulary words for you here, some things that you need to know. All right, this is a real basic form of an absolute value equation or function. Okay, you'll have a value inside the absolute value and a value outside, and we'll call that h and k. So your vertex is the minimum or maximum of the graph, and it's always the point hk. So k comes from here, whatever number that is, and h comes from here. One thing that you always need to remember is that h is opposite in sign, or the sign of h is always opposite. So if this is negative, this is going to be positive. If this is x plus h, then this is going to be negative. So you need to make sure that you switch the sign there. Okay, the same thing for the axis of symmetry. So the axis of symmetry is the vertical line x equals h. Okay, so make sure that when you take h from the equation that you switch the sign. Okay, the last thing that you need to know are your zeros. They're the same thing as solution, x-intercept, or roots. Okay, all of these terms are interchangeable. They mean the same thing. And the easiest way to think about it is as your x-intercept. So where does your graph cross the x-axis? So given this information, you should be able to look at an absolute value function and tell me what the axis of symmetry is and what the vertex is. So remember, this is x minus h plus k. Your vertex is the point hk, and your axis of symmetry is the line x equals h. So when we set this up, our axis of symmetry is the line x equals h. Well, that's -4, so when we change it to a +4. You don't have to write that plus there, I just wrote it so you can see how it changes. The same thing with the vertex. You have your h and your k. H is -4, so we change it to a positive. K stays the same. So if you were graphing this function right here, you should automatically know the axis of symmetry and the vertex just by looking at it. And that helps a lot when you begin to graph the equation. So I'm going to give you a few more examples, but I'm only going to do one table because they tend to be a little time consuming. So this is the same function, and I'm just going to give you a couple of values in here. So say I use -5, -1, 0, 2, and 4. Okay, I'm going to show you how we use the axis of symmetry to graph these things. So here I'm going to plug it in. So I plug in -5 for x, -4 plus 5. Okay, -5 minus 4 is -9, so we have the absolute value of -9 plus 5. When we take the absolute value of something, it becomes positive. So there we have 14. So then if we're graphing it, that's the point -5, 14. Let's do a few more. We have the absolute value of -1 minus 4 plus 5. -1 minus 4 is -5 plus 5. This becomes a positive. So we have 5 plus 5, which is 10. We're moving this way. So if you're plotting the point, that's the point -1, 10. If we have 0, we have 0 minus 4 plus 5. 0 minus 4 plus 5 is -4 plus 5, which becomes +4 plus 5, which becomes 9. Okay, so if we were plotting that point, that would be the point 0, 9. I'm only going to do one more. Let's do 2. So we have the absolute value of 2 minus 4 plus 5. 2 minus 4 is -2 plus 5. The absolute value of -2 is +2 plus 5 is equal to 7. So then we have the point 2 and 7. So if we wanted to plot that, when we start graphing, we have our points. We know our vertex is the point 4, 5. We know our axis of symmetry is the line x equals 4. So we start to set it up. You always start graphing at the vertex. 1, 2, 3, 4, 1, 2, 3, 4, 5. That's your vertex. Your axis of symmetry is the vertical line that passes straight through that. So that's your axis of symmetry, x equals 4. And now I'm going to start plotting these points. I have -5 and 14. 1, 2, 3, 4, 5, and it's going to be off the grid. It's going to be over there. -1 and 10, 0 and 9, and 2 and 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we have the left-hand side of this graph, which we know looks something like this. It always continues up, so you want to make sure that you put the arrows at the end. Now, the thing about the axis of symmetry is that you know that if we took this graph and we folded it in half, it would be exactly the same, which means that these points here are mirrored on this side here. So instead of having to actually fill out a table, you could just plot the points that you found on one side on the other. Now, the way you do it, it's the distance from your axis of symmetry out. So if I start here, this point right here is 1, 2 spaces over. So I can go 1, 2 spaces in the other direction. Same thing here, I have 1, 2, 3, 4 out. I can go 4 in the other direction. 1, 2, 3, 4, and I have a point there. Same thing here, and the same thing up there. Okay, so I could draw the other half of my graph and know exactly where it's going without having to do a table of values. Okay, I have one more example for you, and then some practice problems. I'm not going to do a table here. I'm just going to kind of set it up. So if we're looking here, we know that our axis of symmetry is the line x equals h, and our vertex is hk. Now, you know that h is inside here. So there's no h here. So h is actually going to be equal to 0 here, and k is equal to 2. So our axis of symmetry is the line x equals 0, and our vertex is 0, 2. We don't have to change the sign here because it's just 0. So we know our axis of symmetry and our vertex. Now I'm just going to do 2 points here, and we'll do -4, -2, and 0. So I have 1/2 times -4 plus 2. So that turns into a positive. So 1/2 times +4 plus 2. We multiply first. So we have 4 over 2 plus 2, which becomes 2 plus 2, which is 4. So then our point here is the point -4, 4. Same thing here, 1/2 times the absolute value of -2 plus 2 becomes 1/2 times +2 plus 2. That we group together. 2 over 2 plus 2, which becomes 1 plus 2 is 3. So then we have the point -2 and 3, and then that's it. So I have 2 points here, so I'm going to go ahead and sketch my graph. Put this up. Okay, so here's our equation. We know that our vertex was at 0, 2, and our axis of symmetry was the line x equals 0. So you start at the vertex, 0, 2, axis of symmetry through the middle. Okay, that's the line x equals 0. Oh, I forgot to do zeros. Okay, so then we plot our points. We have -4, 4, 1, 2, 3, 4, 1, 2, 3, 4, and -2, 3, 1, 2, 1, 2, 3. Okay, so then we see that our line here looks something like this. Now I'm going to use my axis of symmetry to plot a few more points. 1, 2, 1, 2. This goes 4, 1, 2, 3, 4. Okay, so then I know that my right side of the graph is going to look like this. Now, zeros occur when the graph crosses this line right here. This graph does not cross here, so the zeros are none. Okay, I didn't cover that here on this graph. Again, the zeros occur here. The graph does not cross the line, so here it's none. Now you can have more than 1 0, so if you had like a graph like this, that would look something like that, then you would have a 0 here and here. okay? So then you would just list the zeros at 0 and, you know, whatever that value is. So that's all you're doing. Here are some practice problems. So when you practice them, make sure that you graph them, find the axis of symmetry, the vertex, the zeros, and then you may want to create a table of values to make sure that you're doing it correctly. If you have any questions, let me know, shoot me an email, or remind. Otherwise, I'll see you in class.